Hey guys, it is Monday. Hopefully you guys are on your Chromebooks and you're checking out this video. We're going to do a little video lesson today on just primitive composite shapes. Do a few examples together, should be pretty quick, and then you guys are going to do some practice for this period, and tomorrow you'll have a assignment on primitive composite shapes. I do want to say on the course website too, under today's date, you'll see a video or two I've linked to Khan Academy, which is some more examples of finding area and primitive composite shapes. You may just want to watch those too later, and you might find those helpful. Also, what was I going to say? I might come back to me. Let's actually just get started. So we've already done area of composite shapes. To find perimeter of composite shapes, what we have to do is simply determine the length of all sides that make up this is important, the outside of the shape. So with composite areas, we broke the composite shape up into basic shapes, and then we added up all those basic shapes, or sometimes subtracted if there was a cutout. But perimeter is easier. Just determine the length of all the sides on the outside, so maybe use a highlighter or a bold pen or something, and add up those sides. That's all there is to it. It's pretty straightforward. We can all do composite perimeter. So let's go to the first example here. So we're doing the perimeter of this composite shape. So I have mentioned that it may be helpful to use a highlighter to trace around the outside. So I might just use a little colored pen here and just emphasize the perimeter of this shape. So all of these lengths, we have to determine the length of all these sides I'm outlining. And once we know all of those, we'll be able to just add them up. And that's all there is to it. So we don't need to break it down into basic shapes. It's just as simple as, hey, what makes up the outside, and total everything up. Something we've talked about and you might have to use is, remember these ticks you see mean that those sides are the same length. So these two sides here are both 1.5 meters, as well as all these ticks around the corners of the shape. Both of these double tick sides will be 7, and both of these triple tick sides will be 13. So we actually know all the side lengths in this particular composite shape. So let's do a calculation to find the composite perimeter. So I'm going to start here, and then just actually do I'm going to show you guys two ways that you can, write out a calculation to do this. One way is kind of a longer way, and one way is kind of like more efficient. So I want to see what you're calculating. So show me. So I use P for perimeter, and I'll start at the top. So 13, and I'm going to work my way around clockwise. So then I have a 1.5 side. So I've done this side, plus 1.5. That's this side, and I'll just keep going. So then there's my 7 side, and then I have my two 1.5s. Now I'm going to show you guys a much quicker way to do this in a second. 7, 1.5, 1.5. The bottom is another 13, and then another two 1.5s in the bottom left, 7 on the left, and another two 1.5s in the top left. And yeah, you know what? That's like kind of a lot to add up. It's just kind of a cumbersome calculation. Like, it takes up a lot of space, but it still works just fine. So you guys maybe take a moment and do that. But I believe what you guys should get is, I'm just doing the mental math right now myself actually, 16, 23, 26, 39, 42, I just realized that decimal should be over here. That's 1.5, it's not. 15. So you guys were just totaling all this up. That shouldn't be there. 42, 49. So I'm getting 52 when I do that, but you can kind of see why it's like challenging to write out all the additions, because even I kind of lost track of, like, for a second there, of what I was adding. It could be a bit easier, and it'd be very worthwhile for you guys to do this on your page too, to just think about, okay, well, how much of each side do I actually have? Like, instead of writing 13 like twice, well, can I just write 2 times 13? That's a lot easier. And especially with the 1.5s, because if you take a moment with the 1.5s, you can see we have 1, 2, 3, 4, 5, 6, 7, 8 of them. So instead of writing 1.5 8 times, it's much quicker to write 8 times 1.5, and then I have 2 of the 7 meter sides. And this is just a lot easier to calculate, right? It's just like a lot less work. 2 times 13 is 26. 8 times 1.5 is 12. And 2 times 7 is 14. And then you can add those up quick. And you get 52. So I think not only is it less writing and more efficient, it also is a bit easier to stay organized. So we've done one example there. Let's look at an example, and just you can pause this video to take things down. You can go back in the video, right? Like, do whatever you got to do and go at your own pace. Let's go on to the next example. So this is our first example where we have a curved side. So as I mentioned earlier, maybe you want to highlight the outside. So we've got a 13 centimeter side, 9.2 centimeter side. This bottom side is also going to be 13 centimeters. But there's one side we don't know, and that's this curved side. If we knew the length of this curved side that I'm highlighting right now, then we just have to add up the length of those 4 sides. But this is the first example. We need to actually calculate the length of that third side. And it's not overwhelming to do. We have all the skills we need. That curved section is just like, it's just that curved part of a semicircle, right guys? And if we think about it, the diameter of that semicircle is 9.2 centimeters. So we have experience actually calculating these curved sections. So I'm going to do it up in my space to the top right here. You guys should do it with me too. I'm going to use C for that curved section just to help me stay organized. It's a circle, it's a half circle, and we have the diameter of that circle, right? It's 9.2 centimeters. So I'm going to use the version on our formula sheets where we take the circumference of a circle is pi times the diameter, but we don't have a full circle here, we have a half circle. So I'm going to divide by 2 because we have a half circle. I'm going to divide by 2. And we actually have everything laid out here. All we have to do is actually just finish it off and execute. So this is 3.14 times 9.2 and then divided by 2. So pretty not too bad for us to do on our calculators. So let's hammer that out. And then once we know this curved side, we'll be basically done. We can just add up all of our side lengths, because that's how we do perimeter, right? Just add up all the lengths of the sides. It's really a little bit easier than doing area, not as much work. So you guys should do it too, and just double check. To 1 decimal place, I got 14.4, and this would be centimeters. So this curved section we found out was 14.4, and now we have all our sides. So finding the perimeter is as easy as adding them all up. So I'll start with the top, 13. On the left we have 9.2. On the bottom, another 13. And the unknown we just calculated, that curved side, is 14.4. And yeah, we just got to total those guys up. And I'll do that right now. So 26 plus 9.2 And you guys should do it too. And make sure you get the same thing. So I got 49.6 centimeters is the perimeter of this composite shape. So not only do you guys have to be able to recognize, hey, in our previous example, that hey, if there's a bunch of ticks, I actually know that those sides are the same length as the other sides of the ticks. Some problems you might have to do, calculate a curved length by using the formula for the circumference of a circle, and then maybe divided by 2, or if it's a quarter circle, like if it was a quarter circle like this, you'd have to divide by 4. So just, you may have to problem solve like that, and then just add up the sides. Alright, one more for you guys to try. On the back, it's a little bit more of a involved perimeter. Lots going on here, but remember, we're not finding the area of the shape right now, we're finding the perimeter. So we don't have to worry about breaking this up into basic shapes. We can just go at the perimeter by thinking of what sides make up the outside, find all those sides, and add them up. I'd like you guys to pause the video at this point and give this one a try. See if you can determine all the unknown sides, even the curved side, total things up, and see how you do. Compare with a neighbor, see what sides you included and they included, and what values you have. And then once you've done that on your own, you've tried it, you've compared with some people around you, then you can play the video from there, and then I'll do my solution as well, and you can check that out. Okay, so you can pause it now. Alright, so I'm assuming now you've tried it on your own, you've unpaused the video, and let's actually look at a solution for this one. So I'm going to use a colored pen here to just mark out the outside and just even, whoops, you guys don't need that, and mark out the outside of my shape. So I'm going to use, hey, just hit the screen grab by accident there, so we should go back to, there we go. Let's use blue. So I need this side, and because of the double ticks, I know that that's equal to 3 centimeters. Whoops, I think I'll just do that again. Do those guys. So yeah, 3 centimeters, and then 10, have that. I have this 3 centimeters, this one is 8, this one is 4, this one is 6, given that. This one, single tick, also 6. And the one length we're actually not given is this one, the curved section. But we have experience doing that. This curved section length, it's a half circle. The circumference would then be pi times the diameter of that circle, but it's a half circle, so we'll divide by 2. And I guess the only thing left to reason out is, well, what is the actual diameter? Well, if we look across the shape, it's just like, this is just kind of like a rectangle here, and you can see that this length would also be 8 centimeters from the top to the bottom there. So we actually do know the diameter, it would be 8. So 3.14 times 8 divided by 2, and I believe that is 12.56 centimeters. And now that you know all of the side lengths, all that's left to do is add them up. So I'm going to start with the 3 on the top left, and just work my way clockwise. So 3 plus 10 plus 3 plus 8 plus 4, just working my way around, plus 6, plus another 6, and then our curved length was 12.56. Those are all of our sides. To get composite perimeter, we just add them all up. So I believe that is 52.56 centimeters once you add up everything. And yes, that looks good to me. So maybe you rounded to 12.6 here, and that's okay, because I usually do that too. So maybe you have 52.6. That's okay. Like that's totally fine. So yeah, things to remember: to find perimeter, it's just adding up all the outside lengths, no subtracting. Just find those lengths and add them up. Sometimes you might need to use, look for those ticks that tell you that two sides are the same length. Sometimes you'll have to reason out a side length, like we did here. We had to calculate that length of that half circle by using circumference divided by 2. At this point, you guys have these nice 3 examples in your notes. Maybe you want to re-watch and you can fast forward or what have you, just to make sure you have it down. I also have some Khan Academy resources on the website too. You can watch those videos if you'd like, and if you'd like to do those examples as well in your notes, that's fine. Otherwise, at this point, you're gonna do some practice that you guys have, and yeah, hope you have a great rest of the day. Work hard. Tomorrow, you guys will have an assignment based on this composite perimeter stuff. And there'll be a bit of extra practice in case you've done that as well. All right, guys, have a great day, and we'll talk to you guys soon.